Our title today is gases. We will begin our study of this phase of matter, looking at all different aspects about gases. So, the first thing we know about gases, and I know you know this from a long ways back in your education, is that gas is a phase of matter that has no definite shape and no definite volume, meaning that it will take the shape of whatever container you put it in, as well as the fact that it will take up as much space as you give it room to. Therefore, we say that a gas uniformly fills any container. So it will take up all the space. It will spread out to take up all the space that you give it. But consequently, or conversely, we can compress it. So that means that if we want to take that gas and we want to move it into a container that has a smaller volume, we can do that, because the space between gas particles is vast. As well as the fact that if we mix it with any other gas, it mixes completely. If we've got a sample that's got oxygen gas and nitrogen gas, the oxygen isn't going to inhabit one part of the container, and the nitrogen gas inhabit the other part of the container, but they will mix together uniformly. Gases apply force. They press on us. We don't notice that because we're used to it, but of course the atmosphere is pressing down on us all the time. So gases apply force, and we think of this in terms of pressure, force per unit area. And if you're a weather person, you know that one of the big measurements of weather is actually air pressure. How much is air pressing down on us at any given time? So the higher we go in altitude, the less air there is. And so air pressure is less. The closer we come to sea level, the more dense the air is, and air pressure is greater. We don't notice air pressure because, again, we were born into it. And so says Newton's third law: for every action force is an equal and opposite reaction force. And so we press out with exactly the same amount of force that air pressure is pressing on us. So if we go up into space where there is no air and there is no pressure, what will we do? What will our bodies do? Why do astronauts wear those puffy spacesuits? Think about that. All right, so we're familiar with gas, even though we don't realize it, but it's all around us. It surrounds us at all times. Okay, and pressure, of course, is force per unit area. We know that from physics. Pressure has lots of different units. This is what we use mostly in chemistry, is 1 atmosphere, 1 ATM, 1 standard atmosphere. And at sea level, that's where this comes from. At sea level, air pressure is 1 ATM. One atmosphere of pressure is equal to 760 millimeters of mercury. So we use barometers to measure air pressure. They work, well, not the same as a thermometer, but similar. And so if a column of mercury is 760 millimeters high, we say that this is 1 ATM of pressure. I'd show you a mercury barometer, but hazardous waste has removed it from our classroom, so we no longer can show the mercury barometer. We could also see pressure reported in torr, torricellis, named after the Italian physicist who first came up with the idea of a barometer. Okay, so 760 millimeters of mercury are identical to 760 torr. So that means that 1 ATM is equal to 760 torr. Essentially, these two things are identical. You might also see pressure reported in pascals. 1 ATM is equal to 10 to the 5th pascals. Now we get to go back to physics. What's a pascal? Can't we get pressure in something that we're familiar with from physics? Well, yes, we can. A pascal is equal to a Newton meter squared. Okay, so 1 pascal is a Newton meter squared. All right, so we're going to spend some time converting back and forth between these units to become familiar with these units. And what we've neglected to say is, if you watch the weather at all, how is air pressure reported in terms of weather? It's inches of mercury. Inches of mercury. So in general, in San Diego, our air pressure is about 30 inches of mercury. Oh, and I'm sure there's other units for pressure, but here, here, here. So ATM, millimeters of mercury, torr, those are the ones that we're